we did research on how to quantify the economic and ecological benefits, and yeah, as I already was introduced, we did it with Wageningen Research and also with DTU, but also with a lot of other participants, especially for experimental results, but also for expert inputs. Let me go to the next slide. So, yeah, how to quantify economic and ecological benefits. So I think now the NoAW's ambition is clear. We want to generate products from agricultural waste, and by doing that we can contribute to sustainable development and also to sustainable or to a profitable business. But of course that's only valid under the right conditions. Of course you need to have feedstock availability, but also select the right technology, select the right production scale. Well, there are a lot of factors which are relevant to be and sustainable and profitable. And yeah, as it is now, eco-efficient products are often not economic feasible in the current conditions. But of course, it's very relevant to research which options are most feasible and how can we change the conditions that it can become feasible. To do so, well, we looked at different potential products, and for these products we made conceptual process designs at the relevant scale, which is also important, of course. To do this we used experimental data, which was already presented this morning for a part. Then we made a techno-economic assessment. So we looked at capital expenditure and operational expenditure, also at profit. And there was life cycle assessments made, and then we combined both the techno-economic assessment and the life cycle assessment by multiple criteria decision analysis, and we use TOPSIS, which is a method, a calculation method to be able to combine different factors. We demonstrated this approach by two cases, which are both published as a paper. One focused on the combined technology solvent selection for polyphenol extraction from red wine pomace, and the other one focused at anaerobic digestion and crude PHB production. I don't go into detail in this on these two cases, but I will show some results. But if you're very interested, of course, please read those two papers. There's a lot of information in those papers. And then I briefly want to explain the multiple criteria decision analysis and the TOPSIS method. TOPSIS stands for Technique for Order of Preference by Similarity to Ideal Solution. And yeah, it sounds difficult, but in fact it's not that difficult. What it does is if there are multiple scores on multiple factors, then the way to be able to determine the most preferable solution is to look at all the solutions or all the scores at once, and by standardization and weighing, it is able to select the most preferable by which has the shortest distance to the ideal score and the longest distance to the anti-ideal score. And yeah, in this way, compensability is also included, which means that if you have multiple criteria, then a bad criteria is compensated by a good scoring criteria. Of course, there are some attention points. One of them is that, look careful at all criteria you include. So if for example, if one important criteria is not assessed, let's say some subsidies or penalties or emissions, and what was already discussed, persistent plastic pollution, plastic particle pollution, if that's not in your analysis, but it's relevant, then of course, if you present numbers and one of those criteria is not in there, then you're not drawing the right conclusions. So keep that always in mind. Always look very critical at all the relevant criteria. And then I already mentioned compensability, but sometimes compensability is not justifiable. For example, if you have a very toxic pollution and you say, well, that can easily be compensated by another criteria, then of course that's not the case. So also keep that in mind. And then there's the standardization or the normalization and the weighing. How can you apply weighing to completely different criteria? Already discussed this morning, the environmental or the economic aspects. That's very hard to judge. But what we did in this research and in the papers I mentioned, we came up with a weighing profile. So in that case, you say, well, we cannot directly point out or exactly compare environmental and economic aspects, but what we can do, we make this scale. In this example, on the left, there's 100% environmental score, and on the right, it's 100% economic importance. And in this way, you can say, well, if environmental is the most, is completely 100% more important compared to the economics, then we can compare the different scenarios in that way. And on the other side, if we prefer economic above environmental, we can compare it in that way. And as you can see in the middle, there are some crossing lines, and of course that are interesting points. And if you say they're both equal, then you can say what is the changing point, and what does that mean for the solution and for the process design, etc. I won't go into detail on this example, but keep in mind that a weighing profile, well, at least can give insight in what is happening to the total score. Then some minor, some important conclusions, but I only discussed this briefly. So for example, for the combined technology solvent selection for the polyphenol extraction from red wine pomace, using this approach, it came forward that the solvent with the lowest experimentally determined extraction ratio has the highest economic and environmental score. So because in the process design, besides the extraction rate on its own, also solvent regeneration, processing aspects, everything was included. And then it came forward that in this case, the solvent with the lowest extraction ratio was scoring the best. So it's not always obvious what the result is. And then to the anaerobic digestion and the crude PHB production, what is important there to keep in mind, if you're going to produce PHB, then from the agricultural waste, then you reduce the biogas and electricity production. And of course, nowadays, some of these biogas plants, or a lot of these biogas plants, they get credits for the electricity. But of course, if you reduce the production of the electricity, then that influences completely the economic and also the environmental performance, of course. It's not always easy to judge. Going to my conclusions for this presentation, combining the techno-economic assessment and the life cycle assessment by using the multi-criteria decision analysis makes it possible to compare both aspects. But the approach can contribute to the development of agricultural waste management. Of course, it gives insight, and so you can show both the economic and environmental performance, but you also can give some decision support. You can show what aspects are important, and by changing something in the process design, how does the economic and environmental performance change? And therefore, it can also be used as knowledge transfer between science and business. You can translate experimental results on laboratory scale to more to a business case. And with that, I would like to thank you for the attention. But of course, not only for the attention, but also for all contributions, the collaboration, and also for the NoAW experience the last 3-4 years. And please look at the Slido and fill in the answers on there. Thank you.